In this video, we are going to talk about a new topic, which is the diode. The diode is defined as a two-terminal semiconductor device that is used mainly as a switch, or mainly it allows the current to flow in one direction but not in the other direction. And this allows us to use it as an automatic switch, a switch that can be controlled by the circuit elements around it, not manually by our hand. Okay, so the diode, it has a definition from the dictionary and a technical definition. The definition from the dictionary is an electronic device that has two electrodes, positive and negative, or what we call anode and cathode. The positive is called anode, the negative is called cathode, and it is used especially as a rectifier. A rectifier means that it allows only one directional current, like for example the positive direction only, and it doesn't allow the negative current to flow. Okay? Or another definition, a unidirectional device that allows the current to flow in one direction but not in the other direction. Ideally, when we talk about the ideal diode, ideal means the perfect diode that unfortunately doesn't exist in reality. The diode works as, the ideal diode works as either short circuit when you try to push the current in the regular direction of in the forward direction of the diode, or it works as an open circuit if you try to push the current in the reverse direction of the diode. To understand what is the forward direction, what is the reverse direction, this is the symbol that we are going to use for the diode. It has a positive terminal which is connected to the triangle, and a negative terminal which is connected to the line. And if you try to push the current, the positive current, and this is the current that we always use, the positive current. If you try to push the positive current from the positive to the negative, the diode will allow you, and it works as a short circuit. But if you try somehow to push the current in the opposite direction against the arrow from the negative to the positive, then the diode will not allow you to do that, and it works as an open circuit. It's a semiconductor device that will introduce the physical operation and the physical structure of the diode later. However, just for now, it consists of two types of silicon, something called p-type silicon, and the other one is n-type silicon connected together, and then there is a metal on the sides. This metal, the purpose of this metal is to connect the diode to the external wire, to the rest of the circuit, and the metal here is to connect the diode to the external circuit, to the wire that connects it to the external circuit. So we have P silicon and N silicon. The P silicon is represented by a triangle, N silicon is represented by a line. This is the symbol, as I said, that we'll use. So ideally, the diode works as either short circuit if you push the current in the forward direction from the P to the N, or it works as an open circuit. So either short circuit or an open circuit if you try to push the current in the reverse direction. Okay, and hence, if you connect the diode, if you try to connect the diode to like positive voltage from this side and negative voltage from this side, which means that you are trying to push the current from the positive to the negative, then it will work as a short circuit. And short circuit can be represented by what? If we want to plot the IV characteristics, the relation between the current and the voltage of the diode, where this is the current of the diode, and the voltage of the diode is always measured negative here and positive here. If you try to plot the relation between the current and the voltage of the diode, the current and the voltage of the diode, you will see that if the diode works as a short circuit means what? Short circuit means that the voltage across it will be zero, right? The voltage will be zero while the current is going to flow How much will be the current? What is the value of the current? We don't know, because in a short circuit the current can be anything. So in the short circuit, or what we call the forward bias, region, the voltage will be 0 and the current can be anything. That's why we plot a line like this in the characteristics. Be careful, now we are talking about the ideal, the perfect diode, which works as a short circuit under the forward bias. Forward bias means again that you try to push the current in the forward direction of the diode. In this case, the diode works as a short circuit, which means that the voltage will be 0 and the current can take any value. So this line represents the forward bias region. It's a line, but we call it forward bias region. Okay? On the other hand, if you try to push the current in the opposite direction, the diode works as an open circuit. Which means what? Which means that the current will be 0, right? Open circuit means that the current is 0. And open circuit means that there will be a voltage between the two terminals of the diode. We don't know what is the value of this voltage. It can be anything. Under open circuit condition, the voltage can be anything. But for sure, the current will be 0. So in the reverse bias, this is what we call the reverse bias region. So in the reverse bias region, the current will be 0, which means that the current is 0 and the voltage can be anything here. And for sure, the voltage must be negative. The voltage across the diode must be negative. Why? Because if it is positive, then the current is going to flow in the forward direction, right? So under reverse bias, for sure the voltage can have or has to be negative, less than 0. Because if it was greater than 0, if the voltage is greater than 0, if assume that V is greater than or equal 0, this means that there will be a current flowing in this. You are trying to push the current in this direction. If you put V greater than 0, this means that this point has higher voltage than this point, which means that you are trying to push the current in this direction, so the diode will work as a short circuit and the voltage will be 0. But in order to operate in the reverse direction, in order to operate in the reverse bias region and to make the current 0, then the V, the voltage across the diode, must be negative, which means that the voltage here of the P must be less than the voltage of the N, right? If the voltage of the P is less than the voltage of the N, this means that you are trying to push the current from the N to the P and the diode will work as an open circuit. So under reverse bias, the V must be less than 0, it can take any value, and the current will be 0. So this is reverse bias region. While if you try, somehow you connect the diode to an external circuit so that the current is going to flow in this direction, then the diode, the ideal diode, will work as a short circuit and the voltage across it will be 0 and the current will flow in the positive direction, so the current will be positive and can take any value. So this is the characteristics, the IV characteristics of the diode. Again, I will summarize. If you try to push the current in the forward direction of the diode, in the same direction of the arrow, then the current will flow and it can take any value and the diode will work as a short circuit, which means that the voltage will be 0. If you try to apply negative voltage on the diode, which means that the voltage of the N will be higher than the voltage, N is higher than the voltage of the P, you are trying to push the current in the opposite direction, the diode will not allow you to do that and it will work as an open circuit. And open circuit means that the current is 0 while the voltage will be negative, any value that is negative. This is under the open circuit condition. Okay, so ideal diode can be either open circuit with these conditions or short circuit with these two conditions. What determines if the diode is working in the forward bias region. What determines the value of the current? The current will be defined here by the external circuit components, the components that we connect to the diode. It can take any value depending on what are you connecting the diode to. Are you connecting it to just one voltage source and one resistor? Or what's the value of this resistor? What is the value of the voltage source? What is the external connection? This is what determines the value of the current. Same thing here. If the diode is working in the reverse bias region, as we'll see in some examples later, then what determines the value of the reverse bias voltage is the external circuit that we connect around the diode. We have to solve this circuit in order to find the value of the reverse voltage. And we can, of course, control it using the external circuit. For example, let's look at these two simple circuits. We have a diode here, and it is connected to 1 kilo ohm and then 10 volt supply. This is a supply voltage of 10 volt. I know maybe some of you are confused. You used to plot the voltage or the supply or the source like this before, but it's the same. Now it's easier to plot this source, 10 volt, as just one arrow, which means that this point is connected to a 10 volt supply. So this is equivalent to this. This circuit is equivalent to this circuit, okay? But for simplicity, we are going to use this notations or this kind of symbols to represent a supply that looks like this. So this means, when we plot it, this means that this point is connected to a source of 10 volt, okay? So let's look at these circuits. We have a diode connected to a resistor 1 kilo ohm and a source voltage of 10 volt. Of course, if you have a 10 volt source here and this is a ground, what do you expect? You expect that the current is going to flow from the 10 volt supply towards the ground. So you are pushing the current now in the forward direction of the diode, right? So what do you expect? The diode will work as open circuit or short circuit. You are trying to push the current in the forward direction. So the diode is going to work as a short circuit, which means that the diode works as a short circuit. This means that you can plot the circuit like this. Now, the diode, here is the diode, it's short circuit, okay? This is the resistance 1 kilo ohm and this is 10 volt supply. So the voltage across the diode, V diode will be 0, right? Because it's a short circuit. What about the current of the diode? The current of the diode, let's call it I or ID, doesn't matter. The current of the diode here equals what? Equals 10 minus 0 over 1 kilo ohm. ID equals 10 minus 0 over 1 kilo ohm, which is 10 milliampere, right? So as I said, the current of the diode under forward bias condition, the current of the diode will be determined by the external circuit components, by the supply voltage and the resistance that you connect, okay? On the other hand, here if we reverse the diode, then you expect that the diode will work as open circuit. Why? Because you are trying to push the current opposite to the arrow, right? You are trying to push the current in the reverse direction of the diode. So the diode works as an open circuit, and if it works as an open circuit, this means that the current will be 0. So if it works as an open circuit, this means that the current of the diode will be 0. What about the voltage of the diode? This is reverse bias, right? Reverse bias, we said that the current will be 0, but the voltage will be determined by the external circuit component. So let's see how the voltage is determined by the external circuit components here. This is 10 volt, this is 1 kilo ohm. So here, if we have an open circuit, this point is connected to the ground, so its volt will be 0 volt. What about this point? This point is connected to 10 volt supply and the resistor, but there is no current here. The current in the resistor is 0, so there is no voltage drop across the resistor, and the voltage of this point is 10 volt. So what is VD now? VD now will be 10 minus 0, which will be 10 volt. So here the voltage of the diode under reverse bias condition is determined by the external circuit components. Okay? Fine. To motivate you about the importance of the diode, how we can benefit from the idea of the diode, I will show you quickly some applications of the diode. And later we'll come back to these applications and study them in details. But the first application is called the rectifier circuit, which looks like this. We have a sinusoidal source here, a sinusoidal source that looks like a sine wave, and then a diode resistance. And we take the output of our circuit. The output of our circuit will be taken from the voltage across the resistor. Let's now think about if the input voltage, if the source voltage, it's a sinusoidal wave, like something like this. This is fine. This is the source voltage, okay, or V input, VI. Okay. What would be the output? What would be the output voltage? Assuming that this is an ideal diode. Of course, in the positive half cycle, when V input is positive, in the positive half cycle, when V input is positive, you are trying to push the current like this, right? In the forward direction of the diode. So the diode works as a short circuit. So in the positive half cycle, the diode works as a short circuit. In this case, the voltage at the output will be equal exactly to the voltage at the input, right? So the voltage across the resistor will be equal to V input. So in the positive half cycle, the diode works as a short circuit, and in this case, the voltage at the output voltage, will be the same exactly as the input. What about in the negative half cycle? In the negative half cycle, when V input is negative, then you are trying to push the current in the opposite direction, in the reverse direction of the diode. So the diode works as an open circuit. So in the negative half cycle, the diode works as an open circuit, right? And if the diode works as an open circuit, look at this now. What is the value of the output voltage? The value of the output voltage will be 0 because there is no current in this resistor. There is nothing, so the output voltage will be 0. So during the negative half cycle here, the output voltage will be 0. And then comes the positive half cycle again. The output voltage will be the same as the input. Negative half cycle, the output voltage will be 0, and so on. So here, this circuit is used as something called the rectifier circuit, the half-wave rectifier circuit, which means that rectifier means that it will pass only the positive side of the waveform, and it will not pass the negative side. If you want this, here we plotted V input with the time, V output with the time. You can also, for this circuit, plot V output against V input. You will find that when V input is positive, okay, V output will be equal to V input, exactly the same. When V input is negative, as in the second case, V input is negative, V output will be 0. So this is the relation, or what we call the transfer function of this circuit, the transfer function of this circuit. So we plotted V input to time, V output to time, and the transfer function. This circuit is very important because we use it as the first stage of the AC to DC converter, the adapter that you use in your computer that converts the AC voltage from the electricity company to a DC voltage that you use for your electronics, your computer, your TV. Okay, this represents the first stage of this adapter, which is first you rectify the AC voltage to make it all positive. Okay, so this is one application of the diode. Okay, another application of the diode is the diode logic circuits. Maybe you will postpone it to the next video, inshallah.